Okay, folks, moving on to 6.2, number 62. Little typo, they accidentally put an X. I should put a W there. W squared plus 10W plus 21. So here's the game. You're just trying to figure out, let's go back in time. Well, let's just do the answer really quickly. What times what is 21, but adds up to 10? Okay, so what times what is 21? 1 times 21 and 3 times 7. Oh, 3 and 7 add up to 10. So this thing would factor as W plus 7, W plus 3. That's the game. But let's just double check. If we were to FOIL, W times W is W squared. W times 3 is 3W, 7W. See how they add up? And 7 times 3 is 21. Oh, they multiply to 21, but they add up to give me 10. Okay, so that's just the game. So we're playing the game backwards. So number 64, b squared plus 14b plus 48. So what times what is 48, but adds up to 14? That's all they want us to do. So 6 times 8 is 48. What's 6 plus 8? 6 plus 8 is 14. Okay. So you could have said, okay, 1 times 48. Does that add up to that? No. 2 times 24. Nope. 3 and 16. Nope. 4 and 12. Nope. 6 and 8. Aha. So it's just a matter of practice. You'll get better and better at this. So I got 6 and 8 really quickly, but I've been doing this for a while. Boom, done. Okay. 68. Q squared minus 13Q plus 36. Okay, so let me show you a little trick. Because there's a positive sign, right, they multiply to get positive, they multiply to get positive, they multiply to get positive. So here's what I say. If there's a positive here, I go, oh, the signs are the same, and they're both that guy. See? Plus, plus. Oh, the signs are the same, and they're both that guy. Oh, okay. The signs are the same, and they're both that guy. Okay. So this needs to look like Q minus something and Q minus something. So far, so good? Okay. So what times what is 36, but adds up to 13? 1 and 36, 2 and 18, 3 and 12, 4 and 9. Oh, 4 and 9. 4 and 9. Negative 4 times negative 9 is positive 36. Negative 4 combined with negative 9 is negative 13. Aha. Okay, so let's see. Did they get a little trickier? Not really. So 78, negative 11 minus 10x plus x squared. Oh, they didn't put it in descending order. Okay, so step number 1, like that's how tricky they can get right now. So they didn't put it in descending order. Well, let's put it in descending order. X squared minus 10x minus 11. Okay, now we're back on familiar grounds. Ooh, minus sign there. So remember over here, if there's a positive, that means the signs are the same and they're both that. The signs are the same and they're both that. If there's a minus, that means the signs are different. So you could say x plus and x minus. Aha. So the minus sign is a little bit trickier. We know the signs are different. And what times what is 11? 11 is prime, so just 1 and 11. Oh, but if I subtract 1 and 11, I get 10. So negative 10. So if I'm, let's see, 1 and 11, it needs to be negative 10. Oh, that's how I do it. So signs are different. That's how it is. So we decided it's 10 and 1, right? Signs are different, and the bigger guy is that. Okay, so we know it's 10 and 1, so the signs are different, and the bigger guy is negative. Okay, so put the 10 here. Oh my gosh. Go back in time. I should probably redo this video, but I won't. 11 times 1. Okay, signs are different, and the bigger guy is that. So 11 and 1. Worst explanation ever. Okay. A negative 11 times 1 is negative 11. Negative 11 plus 1 is negative 10. Aha. Let's see, is there another one? Let's do 74 since I messed that one up. 74. Good gosh. 6n minus 7 plus n squared. Put it in the correct order. N squared plus 6n minus 7. signs are different, and the bigger guy is positive. Okay, n, positive, negative. So the only way to get 7 is 7 times 1. Signs are different, and the bigger guy is positive. So 7 and 1, 7's the bigger guy. 7, 1. Maybe you don't like that logic. Just double check. What's 7 times negative 1? Negative 7. What's positive 7 combined with negative 1? Positive 6. Okay. That explanation was a little bit better. Whew. In the following, factor each trinomial of the form. Okay, so number 80 in them, they just have an extra y going along for the ride. Kind of a boring. It's not tricky. If what we were doing was making sense, this will make sense. P squared minus 8pq minus 65q squared. So notice the form it's in. P squared, P, no P, and then going backwards, Q squared, Q, no Q. Okay, so it's the special form where I like to see it as just Q is going along for the ride. So what if I just, to make things simple, all I'm really seeing when I see this problem, I'm totally ignoring the Q's. All I really see is P squared minus 8P minus 65. And that, I know how to factor. P, signs are different, and the bigger guy is negative. Okay, what times what is 65? Oh gosh. 5 times something. 65 divided by 5. 5 and 13. 5 times 13. Oh, and the difference is 8. Okay, so 5 and 13. So 5 and 13, the bigger guy is negative. 13, 5. What's 5 times negative 13? See, I double check. 5 times negative 13 is negative 65. Positive 5 and a negative 13 combined give me negative 8. Okay, so now all I need to do is add the Q. Done. Because what's 5Q times negative 13Q? Isn't that negative 65Q squared? Right? And then if you were to FOIL, that would give us negative 13PQ, positive 5PQ, giving us a negative 8PQ. You see how the Q just went along for the ride? Hopefully you liked that logic. Trial and error. They just want you to guess. Okay. Oof, trial and error. Let's jump to, so from 90 to, or 89 to 109, they just want you to guess around and figure it out. But let's sneak ahead to like 111, 112. There's a little trick that can help things. It's called our book calls it the AC method. Most people call it the X method. Okay, the X method. I will call it because that's what most people call it. 112. Okay, 8w squared plus 25w plus 3. So here's what we do. We just want to replace this 25w. We want to break it apart. So let's multiply the outside. So maybe that's why they call it the AC method, right? Because if you learn this as ax squared plus bx plus c, like in descending order, ax squared plus bx plus c. This is the a, that's the b, that's the c. So if I multiply those guys, that's 24. And then if I put that middle number, it's 25. So I'm trying to replace the 25. What times what is 24 but adds to 25? 1 and 24, 2 and 12, 3 and 8, 4 and 6. Ooh, 1 and 24. So I could put 1 and 24. Or what if I put 24 and 1? 1, 24, 24, 1. It doesn't matter. Try it both ways. Let's just put 24 and 1. So this is the X method. So notice what happened. So 3 times 8 goes there. And then this number went there. Okay, so multiply 3 times 8, you put 24. This number 25 goes here. And the whole reason we are doing this is I want to replace this 25w with that 24 and 1. World's longest explanation. Okay. 8w squared. Now instead of 25w, I'm going to replace it with 24 and 1. 24w plus 1w. I don't put the 1 because I'm lazy. And then put the plus 3. So notice this 25w was replaced by those values right here. Now we're actually back on familiar grounds. Remember when there's 4 pieces? Back in 6.1, I said focus on the first two. 8w squared plus 24w. What can we pull out from everybody from those first two? An 8w. What does that leave us with? A w plus 3. Okay. Now focus on the last two. A w plus 3. What can I factor out from each of them? Well, nothing really. Yeah, so if there's nothing really, what we put usually is a 1. And then because, you see how I knew what I want this to look like? I want a w plus 3 over there. W plus 3. We're going to need to do another one, I know. Oh, w plus 3 here, w plus 3 here. Let's pull out that w plus 3. What does that leave us with? 8w plus 1. 8w plus 1. Oh, we're using that trick from 6.1 to factor this really easily. Aha. Okay, let's try the next one. 114. 114. We have 5. They use s. I'm going to change it to x because it doesn't matter. Does anything? Okay. 5x squared minus 9x plus 4. X method. What's 5 times 4? 20. Put that number down here. -9. Okay. 20. How can I get -9? Oh. -4 and negative. So 4 and 5 add up to 9, right? But it needs to be negative. So -4, -5. What do you want to put? -4, -5, like that. See how those guys multiply to give 20, but add to give that. So all we're going to do is replace this with this, the x method, because of the AC method. So 5x squared minus 4, x. Make sure you put little x's when you rewrite things, minus 5x plus 4. Okay, so what can we take out of the first one? Just focus on the first two like we did in 6.1. Pull out an x, leaving us with a 5x minus 4. And remember, we've done these problems enough that I know, you see that little thing? I know I'm going to want to get a 5x minus 4 over here. So what did I end up pulling out? A minus 1. Ah, I kind of cheated a little bit. Not really. I just know how these problems work. So I got a 5x minus 4 I can yank out from both of them. And what does that leave me with? An x minus 1. Put it in parentheses. Aha. Okay. One more of these. 114. 116. So the game is the same. All they can do is just give you more annoying, bigger numbers. 6p squared plus p minus 22. Okay, p. That's a 1. 6 times negative 22. Oh, gosh. 6 times 22, negative 132. 132. So negative 132. But they differ by 1. So what times what is negative? So one's positive, one's negative, but when I add them up, they differ by 1. So the numbers are really close, like 10 and 11, or 11 and 12, or 12 or 13, because they differ by 1. This is just from experience. So 11 times 12. 11 times 12. Aha, 11 times 12. Okay. So we have 11 times 12. Let's see, 11. I need to put a negative sign because, right, positive times positive is positive. It needs to be positive 1, so that would mean the negative goes there. 12, if I add those together, I get 1. If I multiply them, I get that. Perfect. So right now you're saying, well, what if I put the 12 on this side and the negative 11 on that side? It's all the same. It'll all work out. Your story will be a little bit different, but at the very end, you'll have the same answer. So do it both ways to prove it to yourself. That all roads do in fact lead to Rome. Okay. So now that I have, I'm just going to swap out right there. So let's rewrite things. 6p squared minus 11p plus 12p. Don't forget the minus 22. Okay, focus on the first two. What can I yank out? 6 and 11, nothing. P squared and p, just a p. P, 6p minus 11. And I know that's going to show up over here, so why don't I just kind of cheat and put it right there already? Okay, so what does that mean I pulled out? Looks like I pulled out a plus 2. Aha, 2p, 12, yep. Hey, it works, amazing. 6p minus 11, 6p minus 11, let's yank it out. What's left? A p plus 2, put it in parentheses, p plus 2. Ta-da! Okay. There's more? What? Factor using substitution. Okay, and then mixed practice. Cool, cool, cool. I much prefer this stuff to solving 3 equations, 3 unknowns. Okay. I think I like this because if you do these, you get better at them. 3 equations, 3 unknowns, just no matter how good you are, it always takes forever. Okay, 128. Substitution. X to the 4th plus 2x squared minus 8. So, tell me if this kind of looks like, let's ignore this. What if the problem was just w squared plus 2w minus 8? You could solve that, right? That's no problem. So essentially, notice how the w is really just an x squared. So if you have an x squared, squared is just x to the 4th. So kind of notice what's really happening is it's just a weird substitution. So let's solve this easier one with w's. So that's just, hopefully you can see this orange marker. Signs are different, and the bigger guy is positive. 2 and 4, so bigger guy is positive. Double check. 4 times negative 2 is negative 8. 4 plus negative 2 is positive 2. Okay. And we said that the w is really just an x squared. Double check. What's x squared times x squared? X to the 4th. Negative 2x squared, positive 4x squared, that's 2x squared. 4 times negative 2, negative 8. Ta-da! Okay. Okay, that probably bugged you. We'll do 130. X to the 4th minus 13x squared minus 30. It looks very similar, right? X 4th, x squared, none. So in my mind, it's basically just w squared minus 13w minus 30. Boom, boom, boom. W, signs are different. Plus, minus 30. 1 and 30. 3 and 10. Is this right? Negative 30, 3 and 10. Let's see. 3 and 10, 5 and 6. 3 and 10, 1 and 30. I feel like they made a typo. Because if it's a minus, does it not factor? Oh my gosh. I was so quick to accuse the book of messing up, but it's really me. Isn't 2 times 15 30? Oh my lordies. So 2 times 15 is 30, and 15 minus 2 is 13. Okay, signs are different. See? I've been doing this forever, and I just need to slow down and focus and maybe even write out all the factors of 30. Okay, multiply to 30. Signs are different. The bigger guy is negative. Okay, so 15 is negative, and that's 2. Negative 15 times positive 2 is negative 30. Negative 15 and a positive 2 combined to give us negative 13. Almost done. The w we said was just an x squared. And go ahead and FOIL that out if you don't believe me to confirm that it is, in fact, that. Okay, 132. 132. 132 looks weird, but It's not bad. It's this whole substitution game. So we need to factor this. I see there's an x minus 2 squared and an x minus 2. So what if I just wrote w squared minus 3w minus 54, right? Because w is just x minus 2. W squared is x minus 2 squared. And this I know how to factor. W, signs are different. Plus, minus, and the bigger guy is negative. 6 times 9 is 54, you get a negative 3, so negative 9, positive 6, double check. Multiply them, negative 54, add them, negative 3, boom. Almost done. So then, what was W? W, we said, was just x minus 2. Weird. X minus 2 plus 6. And then x minus 2 minus 9? Okay. And then clean it up a little bit more. X minus 2 plus 6. Isn't that just an x? I'm not sure. Maybe the answer is written like this and back, but if you go one more step, x minus 2 plus 6 is just x plus 4. X minus 2 minus 9, that's x minus 11. That's probably what the answer would be. Whew. Okay, so now you are good for 6.2.